accurate process simulator, in this case a pressure supply, connected to the process side of the transmitter. A current meter is attached to the output to measure the transmitter's 4 to 20 milliamps output. Ideally, a National Institute for Standards and Testing calibrated simulator and current meter are used. In practice, we can use very accurate process meters and pressure input modules. If we have an analog transmitter, we must adjust 0 and span to reduce the measurement error. With an analog transmitter, there is a 0 and span adjustment on the transmitter itself. 0 adjustment is made to move the output to exactly 4 milliamps when a 0% process measurement is applied to the transmitter. And the span adjustment is made to move the output to exactly 20 milliamps when a 100% process measurement is applied. Unfortunately, with analog transmitters, the 0 and span adjustments are interactive. That is, adjusting one moves the other. Therefore, the calibration is an iterative process to set 0 and span, but only 2 to 3 iterations are usually required. With a digital transmitter, we can adjust the incoming sensor signal by adjusting the analog to digital converter output, which is called sensor trim, and/or the input to the digital to analog converter in the output circuit, which is called 4 to 20 milliamps trim, or output trim. After calibration, the errors are graphed once again. As with the as-found values, there is some degree of hysteresis. However, the maximum deviation has been reduced from 0.38% to 0.18%, well within the tolerance of 0.2%. In this video, you learned the importance of sensor calibration of a measurement signal. Calibration is an adjustment or set of adjustments performed on a sensor or instrument to make that instrument function as accurately or error-free as possible. Proper sensor calibration will yield accurate measurements, which in turn makes good control of the process possible.